Percentage growth and decay. So when dealing with X power of X, it really isn't that much different. It's still got that A, which is your starting amount, your y-intercept, what have you. And then in the parentheses, we have this 1 plus or minus R, which basically makes up that like growth or decay factor. Okay, so it's just for percentages. Now that A is the initial amount, like we've been talking about. The 1 plus or minus R, that's your constant percent rate of change in there. And then which R is your percent increase or decrease. So here's a couple examples here that you can look at for notes there. But let me jump into number 1. Okay, 1 says, Samuel has a vintage comic book worth $360. According to an appraiser, this particular comic's value will increase by 3% each year. Write an equation modeling the value V of Samuel's comic book after X number of years. Okay, so I'm going to use that form of the equation. So let me zoom out a little bit. So I'm going to say V for the value. The initial amount of it was 360. Parentheses. 1. Now it is an increase. Let me underline that. It's an increase of 3%. So I'm going to go plus 3% as a decimal. Got to convert it to a decimal. Is 0.03 to the power of X. So that would be the function. And if you don't remember how to change a percent to a decimal, if I have like 3%, all I got to do is take that there and move it to the left twice. So then you get 0.03. That's how you convert a percent to a decimal. Just move the decimal over twice, or you can divide it by 100. Okay. But to simplify this, I typically like to write it like this: 360 and then 1.03 to the power of X. So I'm going to rewrite it like that because 1 plus 0.03 would just be 1.03. So that's going to show it an increase of 3%. That's growth, right? And it's growth anyways, because that B value in the parentheses is greater than 1.03. So if we keep multiplying by 1.03, it's going to increase, okay? So that would be the function. So use your equation, how much will his book be worth in 10 years? So I would just plug in 10 to the equation. So the value of it is going to be 360, 1.03 to the 10th power. So I'm going to do that math, and I'm going to type that all in at once, okay? Type it all in at once so I don't have to deal with so much rounding during the problem. So 1.03, and then to the power, so I'm going to do yx 10. I got 1.3439, blah, blah, blah. And then I'm going to multiply this by 360. And I got 483, and I'm going to go 2 decimal spots with my rounding because we're talking about money. So 81. So $483.81 would be the estimate. And that makes sense, 3% each year. It's going to increase, so it should be worth more than the $360 it originally was. Okay, let me show you 2. Carly bought a car for $21,000. Each year, its value depreciates by 10%. Write a function modeling the value V of t of Carly's car after t time of years. All right, so I'm going to say V of t. Let me write it off to the left a little bit, actually. V of t equals 21,000. Now it depreciates by 10%. So I'm going to do 1 minus, now 10% as a decimal is 0.1 to the power of t. We're using t as our variable. And that's what it looks like. Now, again, if you don't remember how to convert a percent to a decimal, just take that percent and then move it over twice. That's how I got the 0.1, or you could do 0.10, whatever way you want to write it, but 0.1. So I'm going to kind of simplify this up a little bit. So I'm going to say VT equals 21,000, run out of space. 1 minus 0.1 is 0.9 to the power of t. So that represents that, 10% depreciation. So it says, using your equation, how much money will Carly's car be worth after 3 years? Remember, t represents years. So V of 3 would be 21,000, 0.9 to the power of 3. Let me zoom in so you can see a little better. Which 0.9 to the power of 3 is 0.729, and then I'm going to multiply that by the 21,000. And I got 15,309. So that's how much the car would be estimated to be worth. All right, I hope those 2 examples were sufficient. So you go ahead and try this page, okay? Just be very careful with this. Like, it has gone down, so that's going to be a subtraction with the R. This one's an increase by 2%. So just be careful with that, okay? So you do that page. I'm going to do, I'll let you do 7, but the 7 is just like, is similar to 8. So I'm going to do 8 though. And I'll let you do 7. So subscriptions to a popular video streaming service has been on the decline. The table shows the number of subscribers in millions since 2020. A says find the constant percent rate of change for the decrease in subscribers. Okay. So if you're looking at a table and you're trying to figure out what is the percentage increase or decrease, you can't tell by just looking at it. It's not linear. You can't tell by looking at it. So how we can do this is use division if we're trying to find that percentage. So if I divide this, the 79.6 by the previous, that can tell me what my constant percent rate of change is. So if I did 79.6 divided by 81.2, let's see what approximately that is. I'm going to do a little approximately symbol. It's approximately 0.98. So what that tells me is that each interval here, it's multiplying by 0.98. It's multiplying by 0.98. And that's you wouldn't be able to guess that, but by division, we can figure that out. It's multiplying by 0.98, which means that the constant percent rate of change is 98%. Which obviously means this is a decay. It's decreasing, right? I mean, if we look at it, it goes 81.2, 79.6, 78 is decreasing. This is a decay. So B says, by what percentage of the number of subscribers decreasing each year? Well, if it's a 98%, that means it's a 2% decrease. We're always working off 100%, right? So if it's 98%, it's a 2% decrease. So write an equation to represent the number of subscribers of S, where X is the number of years since 2020. So I'm going to say the subscribers. It started off with 81.2 million, that is. And then I'm going to have a 2% decrease. So I could write, let me move this over a little bit, actually. 81.2. So I could write a 1 minus 0.02x, Or I could write S equals 81.2, 0.98 to the power of x. And I generally prefer this one more after you kind of simplify that. So D says if the trend continues, approximately how many subscribers will there be in 2030? Okay, so in the year 2030, now remember, we were talking about the year 2020, right? So 2030, that's 10 years from 2020. So I'm going to substitute in 10. So I'm going to say the subscribers are going to equal 81.2, 0.98 to the power of 10. So 0.98 to the power of 10, do that on my calculator. Take that and multiply it by the 81.2. And rounding, I got about 66.3. I'm going to put a little approximately symbol. Approximately 66.3. And don't forget, we're talking about millions of subscribers. So this is 66.3 millions of subscribers. It's millions, doesn't 66.3 million of subscribers. Million subscribers. Okay. All right. So I'll let you try the rest.